in this video we want to discuss about the rules assigning of the oxidation number. Okay, so the first rule we are having, that is the uncompound element, or you can say that as a free state element. As you guys all know, in the previous video we have discussed about the free state in the oxidation number 2 free state element. So example we are having, that is the sodium, potassium, calcium, sulfur, manganese. Okay, so they will be having no losing or gaining of electron. They are free state. Okay, so when they will be like positive or negative, okay, when they will be with compound, these are free state. When they will be with any compound, okay, any compound, so then they will be having the positive or negative sign, so that will be indicating that they have lost or gained the electron. But here they are with no compound, which means uncompound. With no compound, they are having the free state. When they are with compound, so then they will be having the property of losing or gaining. Second rule we are having, that is the atoms of homo molecule will be always having the zero oxidation number. So here we are discussing about the diatomic but homo, which means same. For example, hydrogen, chlorine, nitrogen, oxygen, bromine. Okay, so here you can say that these both are same. Diatomic, which means two atom together, so they are related. Two is there, which means they are diatomic, but they are homo molecule, which means they are same. They are same of the same electronegativity, so they will be having no loss or gain of electron. Okay, because they are homo molecule with the zero oxidation number, but here that is the diatomic. Okay, third we are having, that is basically the diatomic. Third we are having, that is the diatomic but hetero molecule. Diatomic but hetero, which means different molecule with same ratio. With how? Let's see. With same ratio of the atom. For example, I'm having the hydrogen. Hydrogen, here is nothing, which means 1. Hydrogen, HCl, you can take the example of HCl, 1. So the first one molecule will be always having the positive sign and second will be having the negative sign. Okay, so if there are 3 molecules, so first will be having positive, second will be having positive sign, then third will be having negative. If there are 2, which means first will be having positive and second will be having negative. So they are diatomic, which means 2 molecules are there, but hetero, which means they are different. Here they were same. Okay, so their ratio will be same, 1:1. Okay, next example, magnesium and oxygen, magnesium oxide. So the ratio is same. It is positive and it is negative. Okay, third we are having, that is the manganese is having the 2, which means, and O is negative, which means that oxygen has gained the 2 electron from the manganese. Positive 2, which means it has lost the electron. Negative 2, which means it has gained the electron. Okay, so the oxygen is having negative 2. Okay, so then the manganese will be having the positive sign. Remember, okay, you have to remember one thing. Fourth we are having, for example, we are having this like negative, which means that it has gained the 3 electron by whom? By aluminum, which means positive 3 because it has gained the electron from the aluminum. So positive 3. Fifth example, let me give you, that is the, for example, phosphorus has gained 3 electron. So 3 electron from home, aluminum, which means positive 3 will be there. Okay, so if the first one is negative, then the second will be the positive. Okay, so if we talk about the ratio, so here you can see the ratio is same. So ratio is same, 1 1 1 1. So the ratio is same, but they are heteromolecule and the diatomic. Fourth one we are having, that is the diatomic, heteromolecule with different atom, How? Let's see. For example, I'm having this, that is 2 aluminum and oxygen 3. So as you guys all know that here you can see that the first will be the positive, which means that if the 3 is there, so here the positive 3 will be there. If the 2 is there, which means negative 2 will be there. Okay, so in next example you can take the calcium and the iodine. Okay, so the calcium is 2 here, so iodine is 2 here, so it will be positive 2 here, 1 is there, which means negative 1 will be there. So the oxidation number, this is the trick of finding the oxidation number. Okay, for example, I have given you the example of this. Here 2 is there, which means positive 2, here 1 is there, which means negative 1. First will be always positive. For example, you can take the example of the magnesium chloride. So here you can say that the chloride is here 2, which means it will be positive 2. Here nothing is there, which means 1, which means here negative 1 will be there. So this is the trick to find the oxidation number. Okay, so the fifth rule we are having, that is the triatomic compound. For example, I'm having the first one, that is the calcium triatomic, which means 3 atom. Okay, calcium, sulfur, oxygen. So here in the previous video I have discussed about that the first one will be positive, second will be negative. If there are the 3 atoms, so first will be positive, second will be positive, and third will be negative. So as you guys all know, the oxidation number of the oxygen, that is -2, which means that 4 multiplied by 2, which means 8, which means the oxygen need 8 electron. Okay, so as you guys all know, in the outer shell of the calcium we are having the positive 2. Okay, which means that the oxygen will gain the 2 electron from the calcium, and the remaining we are having the 6 electron, which means the sulfur will give the 6 electron. So 2 plus 8 is equal to 8. So means that 8 electron will be gained by the calcium and sulfur. Sulfur will give 6 and calcium will give positive. Next, for example, we are having the oxygen. As you guys all know, here the oxygen number is 2, which means 4 oxygen is there, which means 8 electron is won by the oxygen. So from first one you have to remember. Okay, for example, calcium in the outer shell we are having the 1 electron, which means then 1 electron will be gained by the oxygen from calcium. Remaining we are having the from 8, 1 minus 8, which means 7, which means that 7 electron will give iodine to the oxygen. So 8 will be gained by the oxygen. Okay, so the first group will be having the positive for example, we are having in the periodic table we are having the first group. So first group will be having the oxidation number, that will be positive 1, and second group will be having the positive 2, and third group will be having the positive 3. So this is a trick to remember the oxidation number. Okay, so next we are having, that is the, for example, the second I am going to tell you guys about the radical. What is radical? So first one, for example, this is the, here this is this. Okay, so here you can see that we are having the radical. So few atoms are basically combined and they are getting charged, which means that is called the radical. Okay, so first one we are having the example, that is the sulfur with the oxygen. So electron want 2 electron, which means the oxygenation number is -2, and here the electron want 8 electron, but in the outer shell of the sulfur we are having +6. So 2 electron will be gained by the, you can see that from the surrounding, not from the outside. So 2 electron is gained by this. So the 2 we are having, that is the radical. Okay, 2 is the radical. For example, I'm having second example, that is a nitrogen with the oxygen. So here oxidation number of the oxygen is -2, which means the 3 multiplied by 2, which means oxygen needs 6 electrons. So in the outer shell of the nitrogen we are having the +5, which means the 5 electron. So the 5 electron will be gained by the oxygen from nitrogen. So 1 electron is missing. So 1 electron that will be gained by outside. So that outside one we are calling that as a radical. Okay, so let me give you another example. For example, potassium, or not potassium but the phosphorus with the 4th oxygen. So the oxidation number of oxygen is 2, which means it wants 8 electron, but in the outer shell of the phosphorus we are having the 5 electron. So the 3 are remaining. So 3 that will be gained by the outside. So that is the radical. Okay, so if we talk about this, so we are writing this as this, like this, NO3 -1. So this is the, we are writing that as a radical form. So this is what, this is a radical form. Here I have written the oxidation number, but this is the actual radical. This is radical. So the radical, which means the few atoms basically combine and they form a charge, we are calling that as a radical. So these were the rules, okay, assigning of the oxidation number. So we have discussed 6 rules in very detail.